the reduction formula for the integral of the tangent function tan nx dx, how it is deduced and how it is applied. So watch to the end and learn how we deduce the reduction formula for this particular integral and how it is applied to solve integrals of this form. The reduction formula for the integral of tan nx dx. Alright, let's call this I sub n. Okay, this is the sixth reduction formula in this reduction formula series. Watch to the end. Now, I'm going to split this integrand into two parts like this. Tan n minus 2 of x times tan squared x dx. Get it? They have the same base, tan x, but their powers are different, n minus 2, 2. So if I'm multiplying them together, I will add their powers, n minus 2 plus 2, that will be n. That's what I have here. Now, recall that in trigonometry, sec squared x is equal to tan squared x plus 1, which implies that tan squared x is simply sec squared x minus 1. Alright? So in place of tan squared x here, I'll be writing everything I have there. So that I sub n is equal to the integral of tan n minus 2x, then in brackets sec squared x minus 1 dx. Okay? Multiplying that, we have the integral of tan to the n minus 2x times this. That'll be, and this times minus 1 is minus, okay, all into dx. I sub n will be equal to the integral of tan n minus 2x sec squared x minus, okay, dx minus the integral of tan n minus 2x dx. Alright, what we have here, this particular integral, everything here is the same as what we have here, and we call it I sub n. So I'm going to write I sub n here. If you look at this integral and you look at this one, they are similar, okay? Just that we have n here and here we have n minus 2. We call this I sub n. It's like we're saying this is a function of n. So here we now have n minus 2. It's like saying it's a function of n minus 2. So we can now call this I sub n minus 2. Okay? This will remain. We can actually integrate this. We can actually evaluate this. Yes. Look at it. Let me do it somewhere. Let's just work it out. Integral of tan n minus 2x. Let's keep this. Sec squared x dx. Using the technique of integration by substitution. Okay, see, this integral is simply as saying the integral of tan x to the power of n minus 2, you know they are the same thing. This and this are the same, times sec x dx. So I will say let u be equal to tan x. If I differentiate u with respect to x, I will get sec squared x. And this implies that the u is equal to sec squared x dx. Of course, I'm having sec squared, okay, this is sec squared x, pardon. I'm having sec squared x dx here. And here, I'm having sec squared x dx here. So in place of sec squared x dx, I can write the u. And in place of tan x, I'll write u. So this integral will now be the integral of u to the power of n minus 2. In place of sec squared x dx, we have du. So using the rule of integration, we have the integral of, okay, there's no need for integral anymore. It's just to say u to the power of n minus 2, add 1 to it. Then divide this by the power n minus 2 plus 1. Okay, we should have added the constant of integration to it, but there's no need to do that now. And what would this give us? This is u to the power of n minus 2 plus 1, which is n minus 1, right? All over n minus 1. Okay, we can add a constant of integration to it, but this particular scenario is a different case. U is originally tanx, so we replace it with the tanx, tan to the n minus 1 of x all over n minus 1. So I sub n is equal to, this whole integral is now this, tan n minus 1 x divided by n minus 1 minus I sub n minus 2. And this is the reduction formula for the integral of tan to the n of x dx. It's as simple as this. Having deduced the reduction formula for the integral of tan nx dx, let's now evaluate this integral. The integral of tan x all to the power of 7 with respect to x. N here is 7. That means we are evaluating I7. So using this, we have, okay, this is the integral of tan 7x dx, which is equal to 7 minus 1 is 6, 6, 5, right? So we have what is I5? I5 is the integral of tan x all to the power of 5, that's tan 5x dx. So this will be 4, this will be 3. What is I3? I3 is the integral of tan cube x dx. So this will be 3 minus 1, 2, 2, 1. 3 minus 2 is 1. So we have tan square x all over 2 minus I1. So what is I1? I1, which is the integral of tan x to the power of 1. This is it. The integral of the tangent function is actually the negative natural logarithm of the cosine of x, right? We can actually prove this. How is it so? Tan x can be written as tan x dx, can be written as sin x over cos x. So if you look at the bottom, you have the cosine, and the top you have the sine. If you differentiate this cosine function, which is at the bottom, you will get negative sine. Differentiate cos to get minus sine. But at the top, we have a positive sign. So if we attach a minus to it here, it means that we also bring a minus outside. So that minus times minus will give us a plus. It's as if nothing happened. So we have minus, if the integral of a function is such that the derivative of the bottom is equal to what we have at the numerator, like in this case now, differentiate the bottom, you have minus sine x. The integral is the natural logarithm of the bottom. That's it. I can either leave it like this or I write it like this. The law of logarithm says that this minus can stand as a power of cos x here. like this. That's the minus. And so if you invert that cos s because of the minus 1 that it has, and that will lead us to ln 1 over cos x. That's the inverse. And 1 over cos s by trigonometry is actually sec. That's the secant of x. So any of these, they are the same. Now let's go back to the question. What's I7 now? Which is the integral of tan 7x dx. I7 is tan 6s over 6 minus I5. What's I5? In place of I5, I'm going to write this. Put it in the bracket now. This is tan 6x over 6. If you multiply the bracket with the minus 1 outside, you have plus I3. What is I3? I3 is this. So in place of I3, I'll write that. So I3 is tan squared x over 2 minus I1. So what is I1? I1 is, let's use ln sec s, right? Okay, let's use this one first. Minus this. So I'm writing plus, because the minus here times this minus will give us a plus. Minus ln cos s plus c. Sorry, this is I7. What am I writing? This is I7, not I3. So this is correct for I7. Or in terms of sec, it will be tan 6s over 6 minus tan 4x over 4 plus tan squared x over 2. I'm supposed to write minus I1, right? Minus I1. So if I write minus, okay, I1 is ln sec s. In this case, we've used this, so we use ln sec s now. So anyone is correct. Any of these two is okay, right? Now you're done watching. Don't forget to subscribe. Don't forget to like and share this video to your friends and your classmates. Keep watching.